everyone. The object of this video is to model and analyze a 2D frame in SAP 2000 and validate it with an analytical solution by hand. For this purpose, I have a simple frame, geometrically simple. The load, I have them simple in order to provide the schemes that we needed in SAP. This can be a larger model, it can go for 3D. The schemes will be similar. Now, in order to explain the things that were required in SAP, now we have some properties or data that are required that when you're starting an analysis in program, you need those data that you can see them. Now the data will start with geometry. When you need geometry, basically it's the shape of the frame, basically the length, the height, column, beam, those we call them the geometry that we have them, the shape of the frame, and the supports condition that we have them. Hinge, we have roller, fix, or any other combination there, we have it. So we're supposed to know the supports, the type of the frame, members that we have them, the length of them, because we're going to model the geometry first. So the geometry will be done first. Now some you can interchangeable, like sometimes people do this one before or they do this one before, they come back to geometry, but I will go step by step in order to make it easy. So we first create the geometry, then we need some other properties. We need to know about loading type. Now when we talk about loading type, when it comes to program can analyze different type of load, or the load cases we have: dead load, live load, wind, snow, earthquake. Those are the load cases that we have them. Are you going to analyze the frame that you have it for different load cases, or it's just a factored load that you have that you're going to analyze it? Now for the purpose I have it here for this video, I'm having a factored load. So this load, it's including the weight of the beam as well inside it. So I'm assuming that this is including the self weight of the beam. It's a factored load. I'm going to analyze only for one type of load. I don't have dead here, live here. If I had them, I would analyze them. Why? Because we know that load combination is the one that we have to check to see which of the combination is governing the analysis. Or sometime some combination will give more moments. Sometimes the negative moment will be a load in some combination, the positive moment will be in some combination. So program can do those combinations, and according to codes, you know the combination that must be used according to load cases, whether 1.2 dead load, 1.6 live load, the wind, those combination, program can do it for you. Here we're not going to go for those combinations because I only have factored dead load, factored load here. So I'll just be covering it, a type of load which is user defined. It's not one of the cases is there. Now the other data that we needed for the program is section properties, because analysis in program, it required the section property. They're using stiffness method, which the stiffness method depends on the cross-section of the material and the material property. So we need to know the cross-section of the elements, and we need to know the materials that we're using it there. So whether it is steel, or basically goes for modulus of elasticity because of the stiffness, it's dealing with modulus of elasticity. That cross-sectional area will be I, moment of inertia, that the stiffness factor we're using it for analysis. So those information, before going to the program, you must summarize them somewhere, and then if you start modeling it in the program, it will be easy to do because you have the information in hand, and the procedure will be very smoothly going. Now, the example that we have it here, the geometry, I have two columns, one beam, the length of the beam 8 meters, the height of the column is 5 meters. support A, support B, fully fixed, fixed support with A and B. Then the cross section of the cross section is given here, 30 by 30 centimeter. The column's the same, and the beam is 30 by 60 centimeter. E is constant, means the material that we're using it for all of them the same material. So whether you use steel, concrete, whatever you're using it here, it doesn't matter because it's the same material. If you were different, you have to specify each of the materials there. And then the load that I have it here, I have a lateral load, a point load, more specific, a joint load. It's a joint load. I have it here, a point load, and I have a distributed load, 15 kilonewton per meter, and 200 kilonewton, which is lateral load. By the way, this is a big number, but we'll keep it in this way. Now, in order to check the analysis or validate the analysis through program, you always have to do an analysis by hand to check the result from computer with hand analysis. Now remember, in computer, when you make any mistakes, sometimes if you just input this one as 2, the program does not understand it. It will take it as correct value, and the result will not come out correctly, and you may not understand where is the reason why is coming like this, the reason why they're coming out this manner. Remember, we always, when we do analysis by computer, we always check if it's supposed to goes through check. So mainly the check can be done by hand or by different programs, or different ways people are checking it. But I recommend that if you know some hand calculation or the methods that you know them for analysis of frame, wedge moment distribution, slope deflection methods, it can be used to check to see if you have close result there. Now close result, how close you are, supposed to be close enough that to make sure that the analysis is correct. So before going to Revit, before going to analyze this one in SAP 2000, I've made analysis by hand by using Excel for the frame that I have it. So I use the moment distribution methods here. So finding the stiffness factor things, since this is a lateral load, I have it here, so one will be analysis without sway. You may have an idea how to do this analysis. I've done it many trials here to make it as much as I can to make it accurate with the hand. So it's 0.00 something. I stopped here the iteration so that we'll be close to see how close we can get to the analysis with computer. Then the sideway effect has been managed, or like the effect of sideway in the moments, and the final results I have them here. Those will be the final result, the end moments that we have them for AC, which is here, for CA, for CD, DC, DB, and BD, and the reactions will be like. So we're going to check those results, the end moments, through the shear moment diagram from the program that can give it to us, and the reactions to see how close we can get to this answer. Remember, this is going to be something like this. We're creating it and analyzing it in SAP. So I'm going to close this one and we're going to open a new one. When you start SAP 2000, you're going to press on new. This dialog will appear here. Now you have a lot of options here to go, whether you're going for blank, you're going to create by yourself, grid only, beam, 2D truss, 3D truss, 2D frame, 3D frame, and the rest of them, even staircase, because it's a good program for analysis, so you can use it for almost every analysis. So here, since the case I have it is directly here 2D frame, I can select 2D frame here. Well, the units you can check before going the units if it's the one that you wanted. For me, the units here is okay, kilonewton meter. That's okay. So we'll check first the unit, then we're going to choose the case I have it is 2D frame. I'm going to click on 2D frame. Now this dialog will be open here. By this portal I have it here. I mean, there's a braced, if you have a steel structure, the bracing can be there, or different type of bracing. For me, we don't have bracing, so I'm going to go for portal here, portal. Then here, number of stories, for my case is 1 story, I have it here. The number of bay basically means that those we call them bay. Number of bay I have it 1 here. Now the story height for me here it's 5 meter. Since I know that the units are kilonewton meter, so this 5 goes for meter, and the width of this I know it from here, which is 8 meter by 5 meter. Now you may ask what happens if I have 2 bay and they are not equally decided. That can be managed easily. So let's say that you have 2 story. You have 2 story. Set 2 story here, 2 bay, 3 stories, whatever you have it. Then just give something here, then click on the use custom grid spacing. Before going here, I recommend you to at least put the things that you have it here, then you can adjust it there. Let's say I'm gonna go for 2 story by 2 story, 2 story by 2 bay, 5 by 8. I want to adjust them because maybe one of them is 5, the other one is 7, or the height are not the same. Through here you cannot adjust this one, it's gonna be symmetry. So what you have to do, click on the custom grid spacing on edit grid, and will bring you somewhere here. You can go for ordinates or the coordinates, or you can go for spacing. I prefer spacing between them. Some they prefer the coordinates. Now the coordinate, what does it mean? It's grid lines. Now this is x. X for us basically means that we are working in x direction and in the z direction. I have it here. This is the 2 direction you're working here. So in the x is tell me -8, there is -8, then there's a 0 somewhere as a coordinate they're using it, imagining that this is z will be somewhere in the middle. It doesn't matter this coordinate, you can change them. This is, then I have coordinate 0, then I have coordinate -8. So the distance between them 8 meter, as we specify there. Then for the z, we have 1 which is 0, then I have a coordinate 5, then I have a coordinate 10. So it means that coordinate 10 means that the distance between, the grids here, well, let me just try to do it somewhere here to see what do I have in this case. I have 1 grid, 3 grids in the 3 grids for the z, and I have 3 grids in the x. So it will be something like this. This is the grids that we're talking about. Now this is -8, this is -8, this is 0, this is 8, so you know the spacing between them, 8, 8. Then for the z, so this is the first one. For the z, this one is 0, the second one is 5, the height will be 5, the other one is 10, so the height is 10. Let's say I'm changing it to be something that I wanted. Let's say I'm trying to have this one to be 3 meter, and this is to be 4 meter. This is to be 2 meter, this is to be 3 meter. So I can simply adjust those accordingly. From here, the first one, it doesn't matter. I will prefer to start with 0 here. So I will make this one 0 coordinate. The second one will be 3 for me. The other one is going to be 7, because I'm looking at the coordinates 0, 3, 7, the coordinate of the lines there. Then for the height will be 0 to 5. So the goal before me will be 0 to 5. If I adjust them in this way, so I'll just simply adjust them 0 to 5, which is 0 for the first line, the second line will be 2 meter above, and this one will be 5 meter above the 0, which is above the x. You can adjust these things the way that you want it. Now, for my case, I don't need those grading spacing, so I'm going to cancel this one. The case for me, it's 1 story, I have it here, 1 bay, I have it here, 5 is the height story, the bay width is 8 meter. Now those two I will leave them for later, the beam, the section properties, because I prefer to first just create this one and go step by step in the interface to see how we're doing it. So this is the modeling basically here. Sometimes modeling is not easy to be done here, so you go mainly we're doing edit grid. With a grid we will do it. Why? Because it's not easy to just do it with this one. We don't have symmetry cases. My aim here is not to teach you those things, it's just simple things here. Those can be in an object for another videos how to do those basically there. Now I'm gonna press OK here, and it will automatically generate the frame for me. Directly the columns, it will put members along the grid line. So if you had a lot of grid line, it's going to put a lot of member there. Then you can delete them just simply by click over them. If you don't have a member here, you can just simply click on that one and delete. When I highlight it, just press delete. It's going to delete the member there. Let me just close the 3D here. Since I need this one to be there, so I'm not going to delete it, the Control Z to bring it back. Now this is the first thing. We had the model. We said that the first thing is the modeling. So the geometry, I did the shape of the frame, so I can do the support. I can do the support. Now doing the support, we're going to go to assign. We have joint there, and joint we're going to go to restraints. Basically means the supports, we have it, restraints. Then it's gonna, this window is gonna pop up. You see that there is fixed, hinge, roller, and this is no restraints. We have here fixed. So the way to do it, you can click first on this one, fixed, to select the fix. Then you can click on this joint. You can click on the other joint. Both of them will be selected, and just simply apply. Before applying it, make sure you're choosing the fix again, then press apply. It's going to change them to fix. Those already, program is going to take care of them because they are not fixed. Pressing OK here. So this is the geometry been done. Shape of the frame, the supports done. Now I'm going to jump to section property before coming to the load. I'm going to leave to the load later. Now, in order to do those, we have to define some information in SAP. So we will start by defining. In the list of define, they made it in this way: materials, then section property, then we have load pattern if we have load combination. So those things coming in this manner. So first I will provide the material and the section properties, then I will go for the load. I can start with the loads, doesn't matter. Let's say I'm starting with the material here, step by step from here, material. Then we're going to add new material here. Well, according to the region that you're working with, maybe your country will not be here, so I'm going to choose Europe here. Then the material I have it here, let's see, I'm choosing concrete. According to the strengths of the concrete, I can choose it from the list. If you don't have it, you can go for custom. There is from here, you can go user can specify something that they wanted. If it is not within the things that you have, it most probably will be there. Let's say this is the concrete type. I'm using it for all of them, or it can be something else, doesn't matter here. Press OK. This is the material I have it. I'm not going to go for steel here because my aim is not a design procedure. We're not going for design. If it's for design, you will specify the reinforcement properties as well, the longitudinal, the transverse, the stirrups. Then you will use them later for design. That's defining material. Pressing OK. Then we're going to go to define list. Then we go section properties. Now the section property, here we have frame. Those we have other things. Because we are dealing with frame, this is the first one we do. That cable area, the rest can be used for different things. Because it's, as I told you, it's a comprehensive program that it has a lot of things inside it. It can be used for many purposes. For us here, frame sections. Then I'm going to add new property. From there, I'm going to choose concrete since I have concrete. Then the concrete, I have rectangular cross section. Then I'm going to name it first, at least to know what is the name. Let's say this is the beam, I have it. For the beam, cross section is given. It's given to be 30 by 60 centimeter. So we're going to, and for the columns, 30 by 30. By the way, why did I choose that concrete? Because it's constant. I told you I can choose different material here. It does not affect the analysis result here. So we're going to say beam 30 by 60. Recommended to type at least something, because if you have a lot of beams, better to have their name, dimension with the name to remember them. Now the dimension here, since we are working with the units meter, so will be point, the depth will be 0.6, and width going to be 0.3. And then I have to choose the material here, since I already add the material. So sometimes people are going, they don't add the material, they will come here, then they will just add here, they'll take them back to the material definition or defining material. So SAP has always a way to go back to the things that if you forgot to add them. So always there is a way that to go back to them. Let's say you add it here, you don't have it, you don't need to close it. They add something here, add material, you can add it. So add the material, choosing the material. Then I'm gonna go for concrete reinforcement here, because it's frame, so it can be beam and column. So I'm gonna choose beam here. I'm not gonna go for, this is for design purposes, the longitudinal bars, the confinement bars, which is the ties or the stirrups. And then the covering things will be for the design purposes. Not gonna touch them. Even if you change them, will not be a problem. So I'm just gonna choose the beam here, pressing OK. Now the property modifier, I'm not gonna change it here again, because if I go for design, we have to change some modification, stiffness modification, because we know that concrete is cracking at tension, so there's some modification for the stiffness or the moment of inertia, mainly the moment of inertia. We're doing it so that it will represent the concrete in the real life, because concrete is weak in the, or basically we assume that it's cracking under tension. So we're leaving the way it is here. Then those will be, if you want to see the section properties to see what are the material that you have it, you have to double check them before going. Those are, you can check them, or the program is generating those based on the thing that you provided there. Now pressing OK, this is one of them, beam 30 by 60, adding another one for the column, similar concrete, rectangle. Gonna change this one to column, since both of them are the same, so column 30 by 30, that will be enough for us here. Centimeter, changing the dimensions. Now the concrete, the material as well. Then we're gonna go for concrete reinforcement. Here for the column, we have a lot of information. This is going to be the reinforcement, is a circular, the spiral, you have it. Those, because it's always thinking for the design procedure. Just make sure that the reinforcement to be designed here. It's not to be checked, because I'm not going to use those for the analysis purpose. Even though they are there, I can just simply make them to minimum. For example, minimum numbers 2 by 2, 2 by 2, and choosing them as minimum numbers, which does not affect the analysis, but less, because I'm going to design the reinforcement. If you want to use the program, it's for design. So make sure reinforcement to be designed here. Those, leave them, or you can change them, doesn't matter here. So pressing OK, let's make them very small. It doesn't matter, as I told you that. So this is the column, we have it. Pressing OK, I have the two sections there. That's the section property. So in the define, I define material, I define the section property, then I can go for load pattern, or you could use the same way. So loading type basically means load cases and load combination. Now let's see the loading that here we have it. In the define list, we have load patterns. Now first you have to come to load patterns to see the load types. By default, dead load is there. By default, the program has dead load there. Why? Because the program is taking care of the cross-section, the weight for the calculation. Now I don't want this dead load for the analysis. You can delete it or you can leave it there. I want to add the load, I have it. So if you have live load, you can just simply change it here, name it here live, and add the pattern. You have something else, wind, whatever you have it there, you can add them more, gonna give you more. Now I don't have live, I don't have dead, so I'm leaving this one. You can delete it, but leave it there, because I can show it to you from somewhere that if you have multi-loads, how can you see the results for different load pattern. So let's say I'm making this one factored load. I have it here. So I have factored load. It is not dead. I can just simply say it's other. And the self weight must be 0 here, because I said that the load that I have it in this, for this example, the self weight is included. So this is including the self weight. So we're just gonna make sure that the load I have it is 0, because most of or almost all the loads will be 0 except the dead load. So the self weight only will be in the dead load. So anything that you choose it here, the self weight, if it's available there, if it's appearing, must be 0, or by default we make it 0 by itself. It's only for the dead load will be there. So if I just name this one, I need to name it factored load. Why? Because I have to realize that this is the load I have it. So add new pattern. You have to write it, then add new pattern, it will come here. This is the load that I have it there. Pressing OK. Now, if I had load combination, I would have go to load combination there. Since we'll add new combination, or there is default load combination, but since I don't have any load patterns, so live, you have to add live, for example, dead, seismic. Then for according to the design of the program is generating the combination for you. For example, if I double check on this combination, you will see that this is 1.4 dead load. Since here I just have dead load, like for example live, it's taking live as well here because I don't have any even live. I don't have it there. 1.2 dead load, 1.6 live load. So if I had the others, it will appear all of them here. But I don't need those things. So even if you don't do this one, I'm deleting those combos. I don't need them to be in analysis. So in the define, in the load combination, I don't have anything there. Why? Because the case we're dealing with it is a one factor load. I have it there. So this is pretty much the defining procedure we have it there. Remember, this is for the case I have it there. You may have different things. Remember, in the define, whatever you have, it comes here. Whatever you have for the define, it's going to come here. The response spectrum for the analysis for earthquake or wind or the moving load for the road, bridge, everything can be defined here. Now, after defining, you have to assign the things that you have it to the frame, the geometry that you have it, because those are for the geometry. We made them geometry just by the shape and the support. So we have to add those basically to the geometry in order for analysis to get started. Now, in the assign, we already did the joints. We're going to go for the frame. Now we have to tell the program that this is the column. The column is 30 by 30. So I'm going to go to frame section. Then the frame that I already add them will appear there. Now I'm going to click on the beam. Then we're going to click on this beam here. So make sure it's going to select it here. If it's highlighted, then this is selected, just apply. You're going to see the name there. Now automatically we'll add something to them. I'm going to change them. Click on this column. I can click on the other column. They are the same, so I can select them like this, or I can even select with window. That's all possible. Select them, then choose the column this time. Press apply. Now do not press OK unless you're sure that those are the correct dimension you applied them. Check them. This is 30 by 60, this is 30 by 30, this is 30 by 30, and then press OK. So I assigned the cross section. I assigned the cross section here. Now look, those part, all of them are cross section. This is for the cable, tender area, solid. Then gonna come from the load. If you look at it, if you look at the assign, no, it's not allowing me to draw them. So basically this is the frames they have at the joint in the beginning, then the frame, then the load coming here, the load coming there. So after the frame, I only had frame section, then I'm gonna go to load. I have two load. I have joint load, I have frame load. Since I didn't specify lateral load, this one alone, I combine them together. So I'm analyzing it at once, so that's why I only have, I could simply define lateral load, and vertical load, factored lateral load, factored vertical load. So for this case here, we're not going for combination. One name will be enough. I will add both of them at the same category, because the analysis, I'm going to use both of them together for analysis. The idea of separating them, you can if you separate those loads, the result you can show only for this one, you can combine them together as well. So that's why it's recommended sometimes to define the live load alone, dead load alone, because you have the analysis for dead load, you have analysis for the live load, for the wind alone, then the combination between them, all of them together, so you can see all the results separate. Now we're going to go to assign again. We're going to go to joint load. We have force, we don't have displacement. If I had support, settlement, I could go for displacement here, but I only have force. I'm going to go for force. Then according to the case I have it here, this is the x direction, I have it here. Then the force I'm applying it will come somewhere here, and it's in the positive x direction. This is, we have it here, those are the x, y, z, and the moment if you have them. We call them joint force, so it can be moment, it can be force in any direction. By the way, we don't have y because you're only working in x, z, so whether you apply the z or x. If it is going to the opposite direction of the x, you apply minus here, you're applying minus. For me, the force is acting in this direction here, as you can see it here, 200. It's in the x positive direction, so I'm going to choose x and you write 200 kilonewton as positive there. Now before going, we're going to choose the load pattern. That's why you have to be careful. This load I'm applying is under factored load. That's why if you have a lot of load patterns, you have to be very careful when you're selecting those things. It's 200, and here the option that you have it. Now sometimes you're making mistakes, so you can delete, or you want to add extra, you can add to the existing load, or you made a mistake, you can replace it. So those three can be used in different purposes. For me, it's the first time, so I'm replacing the existing load. I can even add to existing load because there is no existing load here. So those two for me is the same. But remember, if you do mistake, when it comes back, it make difference. So if you made a mistake here, if you made a mistake and you pressed OK, you want to change it, you come back, then you can say replace the existing load. For example, I'm going to choose this joint here. Let's click on the joint to make sure it's selected. So this is selected. Then I'm pressing apply. You will see that the load is added here. Now if I made a mistake, I can delete it. I can press delete, click on the joint here to select the joint and just press apply. It's deleting the load. It's deleting the load. So I'm going to do it again, replace. So this is for the replace. If there is nothing, replace is just as adding. Now if I want to, now for the second time, if I made a mistake, I can use replace. I can add to the existing. For example, I want to make it 300, I can add 100 to it, 100 to the existing one. I believe you understand what do I mean here. So for me this is enough. I'm not going to go in detail here. I already add this one here. This is a 200, we had it there. Now I don't have any joint one, so pressing OK here will be enough. Then I'm going to go to assign for the frame load this time. Then frame load I have distributed here. It can be point, it can be distributed, can have some other strain, deformation. I'm going to go for distributed here. So in the distributed, I'll make sure first I'm going to choose the load pattern to be factored load. Now it's gravity, the load type is force. Is it uniform or it's trapezoidal? Trapezoidal basically can be for triangles. You're gonna, in the beginning of the beam is 0, at the end of the beam I can make it something, for example 10. It can be like this, so I'm gonna not make it uniform. I can make it trapezoidal starting from 0. Or basically I have to start in this way, so giving it with this is relative distance. This is what at 0, at 25, and then at 75, and then 100. So I can give these different values if I wanted. But let's say this is starting 3. If I have, then became 8, then became 10. I can add it. Or if I don't, the case I have it here, it's uniform. I can just simply specify the uniform, which is 15 kilonewton. I have it there, 15 kilonewton. The same way you have to select. You can select multi beams if you have it. So selection with whether with the or clicking over them or with this cross section. The window can be selected and press apply. You'll see the load will be applied over the frame there. Now you realize that the other load disappeared. This is normal. Why? Because we are in the distributed load assignment. The other will not be shown here. You press OK, and this is we done almost the modeling every part of it. In order to see the loads before going, now you may be panic, what happened to the lateral load here? It is okay, we can go to display before analyzing it to make sure that every loads we apply them there. So we're going to show objects, object load, assign it. So you can go for the frame. Now we're going to choose the load that we have it, factored load. Press OK. It's going to show you the loads that you added to the frame that you have, the 215 kilonewton downward direction there. Now all the things that I have it here, I made them. Now it's time for analysis and to check with the result that we have it. In order to do the analysis, you go to analysis. First you set the analysis option. Why? Because we have 2D, so we're going to write X, Z plane, we have it here. We're just going to click here. It's going to uncheck some of them because no need for the 3D. If you go for 3D analysis, you need to do for all the variable, degree of freedom, the 6 degree of freedom you have it. It's only we have the 4 degree of freedom, the displacement in the X direction, displacement in the Z direction, and then it's basically the rotation in the rotation we have it here. We only have 3 degree of freedom in this case we have it, because we don't have on the other directions there. It's by default, it's so we have it here, X, Z plane. You're pressing OK here. This is set, analyze. Then you go for run analysis here. Now I don't want the live. The live is there, yes, but I don't want it, so do not run. I'm just gonna click do not run this one. I don't need the dead load, do not run. I don't need the model, I don't need to run this one. Only need to run the factored load. I can leave them, but in order not to confuse myself, I just simply check them to do not run. Just simply click them. This one, run do not run case, and then that's only one I needed. Run, it's the one I needed. You just press run now. It's going to analyze. First it will ask you to save it. Let's save it somewhere, frame 1. Remember, save it somewhere if you want to use it for later. Save it somewhere that you know what I didn't choose anywhere. You can choose desktop or folder to be sure you're saving your files somewhere, because you may come back to it later to adjust things or to get the information. After the analysis is done, you'll be able to see there's this lock here. Let's allow you that it tells you that this has been locked, and at the end we'll right click on any joint for displacement values. So it means that the analysis has been done. Now you'll be able to see that there are some icons here will be activated. I can show the deformation shape just by clicking over here and then choosing the factored load that I have it there. Then press OK. It's gonna show me exaggerated basically, and if you go over any of those joints, it's gonna give you the displacement. Now the units, I can change them in order to see the displacement in millimeter. I can see them. Just go over here. Now we have U1. You see that there are U1, U2, U3. And now basically the U1 goes for X. I mean in the direction of X. This is 57 millimeter. It is moving to the right, and then 0.0223 is coming down. Why? Because we had the vertical load as well. So under the vertical load that we have it here, it's going to come down a bit, and due to the lateral load it's moving away. So we call this one delta sway. So this delta, it's around 57 millimeter. So if you just go over the point, it can be seen there. Now those, we know them, they're fixed. I'm expecting 0 for everything, no rotation, no displacement. Now I can show the shear moment diagram and to check with the things that we have it. So those are the things that we come here. We're going to go for frame, cable tenders, and inside there we're going to first define what we have it, factored load, the one we have it. Then I'm going to go for moments. Now we have what? X, Z. X basically goes for 1, Y is 2, Z is 3. So the case I have it, I'm going to go for moment. Let's say moment, or in moment 2, I'm choosing it here. I don't have, it's moment 3 because of the Z I have it here. Pressing apply, I'm going to see the moments. Now in order to see the values, I can just see show values here, press apply, and I'm going to see the values there. Now let's check the values with the analysis made by hand. Now the units I'm making it kilonewton meter to compare with the one that I have it. Now this is for the case that we have it here, the analysis made by hand. So the which one we're going to check here? There's the moment at, for example, AC, moment at A, which is here we have it 246.6. in SAP it's 247.35. it's close, it's less than 1 kilonewton, you have the difference. Then the moment at this joint here, 219.24, this joint, and in analysis made by hand, which is joint C, the two moments at joint C, they are equal, 219.07, which is pretty good. And in the other joints, 240, 64, and this one 269, I can check them again to see that I have 264, 269. Now those analyses come from the hand. So I can see that the analysis by hand and the one that made by the program, I can say it's all perfect. Then the reaction, I can check them to see if I found the reaction or the program. Well, since it's okay, those are okay, then I'm sure that the reactions will be alright as well. Will be alright. So this is the moment diagram. I can show the shear diagram as well. That's going to be shear 2, I have it here. Press apply, and it's going to be a shear diagram. I have it here. There's a shear diagram, and this is a shear diagram for this case, and this is a shear diagram for the column. So this is for this column, this for this column, and this for the beam. I have it here. This for the beam. I have it there. Then I can go to show the joint. So I have factored load. I can give them as arrow. I can give them tabulated. Tabulated basically show me with numbers directly the F1, F3, M2. F1 goes for Fx, F3 goes for Fz here, which for us we called AY, AX, and this is the moment there. So I'm gonna compare them with the values that I have them in Excel, or the analysis by hand. The analysis by hand, so I can see if they are somehow. This is F1 basically AX. I have minus 93.1432. We know that they must be close. 48 minus 42. This is 247, 246, and the others, the other joint are similar as well. So we can conclude that the analysis that we made by the program is perfect. The conditions are okay, no mistakes there. Now you can print those things that you wanted. If you want to take out those, I believe that in the file you have it export. So you have capture instant, this one, capture enhanced meta file. Capture picture can be used in task screen or main screen. Those can be used, but I can go for this one. Then we're going to save them. This is a meta file, or you can go for the capture screen. Then you can go for the main window. You don't need the entire screen. You don't want those things to appear. You only want the main screen here. This is the reaction. So you can just simply capture this one and say the main window here. We're going to save it somewhere. Let's say this is going to be the reactions. Let me just add them. Reactions. I'll just save on the desktop. So I can just save it on the desktop. Then I can show the other diagrams that I wanted and save them so that to have them and to convert them with to the report if I want to do it. So the moments, I have it there, the moments, and first we'll adjust the view in order to be somehow. Now you can scale those things. Sometimes the values will come inside each other, so you may not be able to read them easily. You can scale those. This is gonna practice to do it. There is something we call user-defined scale. So if the scale, for example, let me make it 0.5 to see what will happen. Maybe big, I don't know. I'm just gonna apply it. It's so big, so I'm gonna go for 0.01. Still okay. If this is okay, if I'm satisfied with this one, I can still make it much more smaller, make it 0.005, let's say 5 here, to see that how does it look like. Seems that pretty Now it's better, I can, at least those are not overlapping. Then I can press OK here. So I can define the scale there. Then I can go to save this one the same manner. And I can call this one moment diagram. The shears also can be done. The joins also, anything that you wanted, you can have it and save them. It can create report, but there's a simple analysis, and you create the reports and the sections. Yeah, in the report, when you're creating report, it's going to give you all the properties that you have it there. You can go for creating report. So report, create a report. That's going to give you the summary of all things that you have, the cross sections, the material, everything. Then let's just save this one as a report as well. Then you can use that report. It's gonna put the things inside it. I didn't go for the print setup or the report setup. There's a lot of things that you can set up there in order to manage whatever you want to be showing in the report. Now let's check that those are the diagram that we had them. Those are the diagram. I believe I used the entire screen came there. Let me just main screen. Just should have just this part I could have selected, but anyway. Then I'm waiting for the report to appear, and from the report I can gather those information as well. Let's see whether the report finished or not yet. I believe it's finished. I believe it's saved. Let's make sure I'll save it in the desktop again to be able to find it easily. This report done, it's opening. Then we can see the material properties, the section properties. I believe it's opening it. It's taking a bit more than usual due to the recording. Yes. So those, the report generated by the program, geometry, the materials, tables, so you can show it. Let's go over them to see if not all the time that they have all the information that we wanted. Sometimes we have to add and set up the, those are the coordination, the restraints basically. And they're not going to say that it's fixed, they're going to say that it's joint restrictions like this. Then the element that you have it, when they give them the names appearing here, the cross section that you have it, those are the materials. Look, every material within the program will come here. So if you don't want them, you can just delete the rest of the material from the program before creating those reports. The rest of them, the material property, rebar data, some of them I not need them, section properties, the one that we have them, and the load patterns, the definition load cases. Then coming to structure result, this is the deformation, and those are basically the joints. As I told you that those are the each joints displacement they give it. Then the reaction they give it here. For the factory load, the reaction they give it here. Then those are another information given as well for the joint displacement. They did joint reaction as well. They give it a tabulated without. Those are the forces. So we have the shear force here, normal force, the shear force we have it here, and then the one will be for the moment as well. I believe there's one for the moment as well. We have it M3. That's why the things that the moments, the end moments will appear inside here. The material takeoff is going to tell you that if you have materials, which kind of material you have it here, the total weight of the structure there. and the rest of the design procedure, since I don't have a design, there will nothing be shown here. I hope you like the video. Thanks for watching.